Well, welcome and thanks for joining today. My name's Caleb Baker. I'm a program manager in the Azure AD team, working in the identity security protection group, and specifically on conditional access policies. And I'm happy and excited to be talking to you about this. This is something that we've been working on for a while to kind of allow apps to like more deeply integrate in with conditional access and really use it to protect that in-app data. So I'm excited to be here. Thanks a lot.
Hello, everyone. My name is Kalyan Krishna. I'm also a program manager in the Azure Active Directory team, focused mostly on developer experiences and developers working to use our platform and Microsoft Graph. Caleb?
All right, so then for the agenda today, I'm just going to start off a little bit talking about zero trust and how it relates to developers with conditional access policy, and then going through some of these concepts around app triggering step-up authentication. And this is just kind of like background about like what's motivating the feature and how it fits into this bigger picture around zero trust. Then Kalyan will talk about the identity platform integration, covering topics like the conditional access auth context, introductions to the scenarios, walkthrough in the demo, and then really getting down into some of the details about how it works at the protocol level. All right, well, so to get started, I'm going to talk about just Microsoft Zero Trust. And you might have already heard this is a story that we're really amplifying and talking to a lot of customers about, particularly with enterprise customers that are facing new security threats and figuring out how to maintain a strong security posture as they move to the cloud, as customers or as their employees are working from any location. So zero trust is really an approach to and a mindset to how to continue to secure your data in this new world where you don't necessarily have like this corporate boundary or have this trusted network that you might be operating in. Some of the principles here, and again, like the reason that I'm kind of going into this is because so many enterprise customers are concerned with this, and they are going to be deploying this type of model. A lot of them are already on their journey. It also has impacts on what they expect from applications in terms of how they can secure the applications and what sort of controls that they have. So that really falls into like how it bleeds into some of the app experiences and app integrations. So some of the principles that they're pivoting around and really how we tell this story is the verify explicitly. So this is don't assume just because someone's from a trusted location or has one trusted aspect of them that they're good and give them full access to everything. But have stronger authentication, have all of those steps in place, use other signals and data to help identify who they are. Use least privilege. This kind of falls more into the space of when you're making Graph API calls to use like that minimum set of permissions. So if something's compromised, there's a lessened impact. And then there's also assume breach. And assume breach is kind of the one that fits the most with the topic today, where assume breach is kind of that assumption that there's always an attacker. Someone's always inside an organization. They have some accounts under their control. And in that situation, how do you minimize the damage of what they can do? How do you keep most sensitive information secure? And one of those core tools there is to be able to segment data, segment actions, so that maybe for like a day-to-day activities, you have a lower bar in terms of authentication. But then to do, get to the really important data, that there's stronger policies in place and you can still maintain those controls. So there's multiple layers that someone would have to break through to really get to like the keys to the kingdom. So I'll just break real quick here since I'm going to be talking now specifically around conditional access, just to level set and know a little bit in terms of like how much detail to go into in the different areas. Toss in the chat, how familiar are you with conditional access? Like, is this a new topic to some of you, or are you pretty familiar? You've set it up, you understand how it's working. So far, it looks like people are pretty solidly in the A camp, so that's great. A+, excellent. Okay, and then a bit of variety. So I'll go through this next slide. And this is just to give a high level view of conditional access. I think a lot of you, it looks like, are familiar with this, but then just to make sure that everyone has that base understanding. So conditional access policy is a authentication access policy engine that runs within Azure Active Directory. And kind of its main function is it looks at kind of the inputs from the sign-in and makes a determination around allowing access or not. So admins can use it to create policies to say things like require multi-factor authentication when a user is signing into a specific application, or require that they're on a healthy compliant device that Intune has verified is following like the corporate MDM policies. That could be a common policy for if someone was, going to be downloading files from that application to their local machine so that the company can keep control over that. The graphic here really shows a lot of the signals that we evaluate and that we can use, including like that user location, IP ranges, the device health, other information about the device. There's the real-time risk, where this is integration with Azure AD identity protection. So if there's some unusual behavior detected, or there's been offline detections that lead us to believe that the account has been compromised, then we can flag that. And then with those signals, we can enforce the policies like that multi-factor authentication, reduce access of that user, or block access. And then that applies to applications in the end in terms of what they're trying to get access to. Now, most of conditional access right now is pivoted around that application access. And this kind of starts really getting into what we're here to talk about today. So if you think about creating one policy, one access policy for an app, I can use like SharePoint as an example here. That if you're making one policy decision for all of the files that live across SharePoint, that can be challenging because it's not like there's just one file that lives on SharePoint. There's a variety of different file types. It could be things from like cafeteria menus up to employee personal information or acquisition information, all within that same app. And across those use cases, we often hear from customers that they have different security requirements. They definitely is not a one-size-fits-all situation. This has been a little bit of a challenge for us since we do all the evaluation based off of that application identity. So we took a bit of a step back to look at how we wanted to be able to provide this support. And the closest pattern, and this is, what we chose to follow, is this pattern around like stepping up or triggering multi-factor authentication from an application. And how this works in other places and like other applications do this piece, because we really wanted to follow like a common pattern that was already out there in the industry, would be that an application could have some code in it that says, I know to access this piece, there has to be a multi-factor authentication, can check within the token, see if there's a claim that expresses multi-factor authentication occurred. If there isn't, then the app can start a new sign-on, trigger a new sign-in, add an additional parameter that'll indicate that multi-factor authentication is needed. Then the identity provider would prompt the user, and after the user's done multi-factor auth, insert that claim in the token so they can pass the authorization check. We have very limited support for that within Azure Active Directory. The example that I have here is from one of our products that uses it. It's around identity management. So for the privileged identity management in Azure, where you can specify that on role activation, someone might have to do multi-factor auth. So that's kind of like the nice basic case, and there's already kind of like some practice out in the industry. But we also hear from customers that it's not just about multi-factor authentication. Kind of going back to like that zero trust story, there's a lot of aspects that people care about: the location information, the health of the device, and they want to be able to apply all of that information to these more granular controls in the app. Here's a few examples that I have here that we heard. One of them, and we have several customers in this situation, is really just having like stronger auth requirement on some SharePoint sites so they can complete their migration from on-prem and move that up into the cloud, or being able to lock down to specific devices. Because we have another feature that's coming out in conditional access where you can target it to a specific set of devices, not just, all compliant devices, which is great for cases where you have like a privileged access workstation or a secure access workstation, and someone would author a policy that says only these devices can interact with a service that's handling some, sensitive DevOps operation or some other service that's critical to the business. And then the other one is location, where with the integration, you can just pick up other controls. Like we've recently added like GPS controls and being able to lock down specific actions in the app that way too. So kind of taking all of that, taking that common pattern, I think we just sort of did the natural extension, which turns out to be pretty powerful. That instead of having the application just be able to code and say, okay, I want to trigger multi-factor authentication, instead the application can reference conditional access policies that an admin has authored. So what's showing on the left here is this sort of dialogue and configuration that could appear within an application where someone who's administering the app can see like what are the available policies that I can use within my application. Behind the scenes there, you also get the identifier that you would use when working with Azure Active Directory. So that then the app can attach that to specific, high value transactions, monetary transactions, whatever the app does. And when you get to that point in the application where it's needed, redirect back to Azure AD, demand that policy be evaluated. And then, once it is, the claim comes back and you allow access. And then I think, one of the powerful things here is that then as we do add all of those things into conditional access, like the GPS coordinates or a specific device, or expand out the type of authentication method supported in conditional access policy, the app just kind of like picks all of those up for free. Since it doesn't need to know about those methods, the coupling is pretty loose. It's just by this claim that's maintained in the application. Okay, so that's kind of like the end of my piece and an intro to just overall the topic. So I'm going to hand over now to Kalyan.
Thank you, Caleb. That was a great introduction to the security policy posturing using the conditional access engine and the zero trust. Okay, so before we get on with the actual development aspects of it, as a quick introduction to the Microsoft Identity Platform, which is a part of the Azure Active Directory product offering. The Identity Platform is a distinct set of tools and libraries, essentially starting with the app registration portal, where you can go and register your applications that you want to authenticate using the Azure Active Directory. We also ship a number of libraries called Microsoft Authentication Libraries, and we will be using those in our demos today. And we have OpenID Connect and OAuth 2 certified endpoints, which allow you to make applications which are protocol independent and quite interoperable. We also have popular APIs like Microsoft Graph and Azure Service Management APIs that you can use to manage your resources and get access to your data in the Microsoft Cloud. We support the various types of identities, the most popular being the Azure AD, Microsoft accounts, which is your Hotmail and Outlook, and a whole set of external identities via our B2C product. And the whole platform is built on open protocols, nothing proprietary, allows us to basically innovate faster and make sure that you do not end up getting locked up with any particular identity provider. Having said that, going on, I'm just going to cover the identity Microsoft Authentication Library in a little bit more detail. We have these available for various platforms, and you will find it quite useful again to program against Azure Active Directory authentication and authorization, and including the feature that we are going to present here today. They abstract a lot of work for you, and we recommend that you can use one of the OpenID compliant libraries, or you should give the Microsoft Authentication Libraries a try when you have a chance. Having said that, let's cover the Conditional Access Auth Context in more detail. As Caleb had very nicely explained, Conditional access is the control plane that allows you to target policies for access to all your applications. And the auth context, or CA auth context as we refer to it, essentially allows you to apply policies within your application. And by that I say different policies within your applications. You now, as a developer, have the power to demand additional policy requirements and controls from within your applications. You don't have to have policies which apply to your entire application, and that's the power that we have brought to you with this. The common scenarios for developers, if you are curious, is like, okay, if somebody is accessing a certain sensitive document, or somebody is carrying out high privilege operations like assigning admin roles to users, or if somebody is carrying out a sensitive operation like transferring funds that you see on the banking sites. So these are the scenarios where you can say, okay, if you are doing A, I'm going to have you do an MFA. Or if you are going to do something like, assign roles, maybe you should not just have done an MFA, but also access the application from a compliant device. Or if it's a very heavily sensitive operation, you can say, not only these, I also want the user to be accessing the application from an IP address range. And you're making these decisions or driving these decisions from within the various operations that you have in your application. So what are we talking about here? So what I'm going to do is I'm going to first start with the end user experience and what they see. And then we will basically unravel it and see what are the various parts that make up this experience. So I have picked up this standard code sample that we have, where we have a client application called To-Do List Client, which uses an API called To-Do List Service. And basically, it creates to-do list items using calls to this web API. So let me just quickly change my screen share to the desktop. And OK, so this is our standard to-do list client, nothing very special. I can sign in using an account. And I can access a to-do list item. I can create a new item, say something like create a new invoice report. I created, and I can go and edit it. And then I can delete it. I'm asked for a confirmation, and I'm able to delete it. Now, the difference here is that we want to make this a little bit of a change, where we want to basically impose a higher bar of authentication when a delete operation occurs. So what we have in this demo or in this sample, and which is shared, I've shared the link to the sample in the deck as well, is that in the web API side, and this is where my web API links, I have an admin portal for the web API. And here I basically do something like fetch these authentication contexts, and just bear with me, is because I will explain it in more detail. And I have these various operations available in my web API. I've picked up post and delete, and I'll say, you know what, if it's a delete operation, I want to have a strong authentication. So I save it. And then I go back here, and I'm going to create another task again as an end user. But this time, when I try to delete this, something else happens. I'm being asked to do an MFA. This is the end user functionality that we want to that we have brought to you. And now, again, I'm back to my delete confirmation screen, and now I'm able to delete it. So this is the exact feature capability that we have brought to you and that we will talk about in this call today. So let's go back to the deck for a second. OK, so this was a quick demo. And what we had seen here is an auth context in actual action, where for a certain action which I have in my application, I was able to ask Azure Active Directory to have the user go through a certain policy. So to meet a certain policy requirement, in this case, do an MFA before they were able to carry out that operation. So what are the various steps that you need to do? So let's start from the beginning. And from the first thing is that we would visit the portal, and we will look at what authentication contexts are. And then we will look at some of the CA policies that use those authentication contexts. So without further ado, let's go to the portal again. And so here we are back at the Azure Active Directory portal. And I'm going to keep increasing my screen size. I'm sorry, there is this top bar on my screen. that is forcing me to not use the full screen mode. I hope it is clear for everyone. So this is the standard Azure portal. From here, I will reach out to my conditional access policy screen by clicking on Azure Active Directory. We just saw that a lot of you are actually familiar with this. So this is how you reach to the conditional access screen. One of the things that you will notice here is a blade called Authentication Context. This is being rolled out as we speak to all the tenants. It might or might not have managed to get to your own tenant, so be patient for a few days if you don't see it. Here, I am being asked to configure. I can see what authentication contexts are available, and I can create new ones. So let's look at this one. So what it essentially is just a name and a description, and it has been given an ID called C1. So just make a note of it, is because we'll be revisiting the C1 ID over and over later in the demonstration. So once I have created an authentication context, and you can go ahead and create more as you wish. So and once you do that, you basically have another authentication context available to you. So what we have done is essentially created authentication contexts. These are entities in themselves, and how do you use them? So you use them in your policies. And this is where the bridge between authentication context and policy becomes available. So once you have the authentication rolled out into your tenant, you can go ahead and create a policy, which could be you want, or you can edit one. You can basically choose your targets. And in this case, I have selected, let's say, a user or a group. So bear with me. And in the cloud apps or actions, you will now also see an authentication context available. Here, my authentication contexts are shown. Now I can pick the authentication context that I want to use. And at that point in time, I can basically start demanding the various grants that we want to impose for this policy. So what we are doing here is saying that if somebody shows up at Azure Active Directory's door, and a user shows up at an Azure, or whoever is on a user and group shows up on the door of Azure Active Directory asking for these authentication contexts, this is what they will have to satisfy. So in my case, I already have one conditional access policy in place, so I'm going to just show it. And this is the policy that we had used. So in my case, in the demo that I just did here, I have these two users. And this authentication context requires strong authentication, which basically requires the users to do an MFA. This is accessible to my application. Now, if you remember, we did in the admin site. So if you remember here in the admin site, I was able to go and retrieve a list of authentication contexts, and I was able to attach it to one of the operations within my application. So this is local to my application. This is what I got from Azure AD. You get it via Microsoft Graph. This is available via the Microsoft Graph API. And bear with me for one more second while I show you which API that is. So it's called Authentication Context Class Reference. And when you are an app developer, you need to have access to Microsoft Graph. You can enumerate the available auth context, show it in your application, and basically make use of it. And this is what we did here. Going back to our deck again, where we will continue doing the configuration. So this is all you do. You create auth context, and then you use it in your CA policies. Once you have those available, you start basically defining operations and actions in your application and start attaching them to auth context. This is a topic, again, we will discuss in a little bit more detail on why we want you to go via the Microsoft Graph route later in the session. But this should be enough for a good start. So going back to the deck again. Now that you have seen how it is configured and I have seen how it works for the end users, let's just discuss the authentication context, what the new entity that you were just introduced to in more detail. It is declared at a tenant level. It has nothing to do with applications. It's a tenant-wide entity. It can change from tenant to tenant. It exists at a tenant level. Applications have no control on it other than to read it. And if they have permissions, add and update new ones using Microsoft Graph. The authentication context is the bridge between the policies and the applications. That's exactly what it is when you look at it from an app developer perspective. It has some notable attributes. The first one is ID. We have at this today we have the IDs available from C1 to C25. Whenever you create an auth context, you are assigned an ID, which is one of the available ones. You can create a total of 25 today, which we expect to be sufficient. But then again, we always learn we can make those changes later. But today, we believe this should be more than enough. And it has a display name that we saw that we show it to the end users or IT admins who are configuring various actions against the authentication context. So in my case, you saw we have 3 different auth contexts available. They were given the IDs of C1, C2, and C3, and these are the texts that we have in front of them. So if you have an app and you want to use auth contexts, what are the various prerequisites that you have to meet today? First of all, today it is built on protocol extensions provided by OpenID Connect and OAuth 2, so only available to applications who use these protocols. We have some planned work in progress to address other types of applications, and we hope to address them in the coming months. But today, it's only available to these applications using these 2 protocols. You also need Azure Active Directory Premium P1, which is mostly from the fact that you need to have this particular SKU if you want to access conditional access. And I'm just adding this obvious part. It's only available to applications that sign in users. There are applications like services and daemons, and they have very limited use in a conditional access policies, and this does not work for them. Okay, so I'm going to just take a quick stop here. And if you have any questions specific to the admin configuration experiences or about the authentication context, we can take them on the chat right now. Okay, I see a number of them showing up now. When will the app proxy sign-in be supported? So app proxy is a type of, okay, I'm going to let Caleb answer the first 2.
So will Azure App Proxy sign-in be supported? Yeah, that's something that we're talking about with the Azure App Proxy team. There's not a timeline right now on that, but there's definitely integration potential there. As you can imagine, there's quite a bit of integration that's possible with this because it's a pretty flexible feature. And it's similar with B2C. Right now, the B2C flow is not supported, but you can easily imagine how this would extend there as well. For the multi-tenanted support, since every organization can define the policies separately, like really how the multi-tenanted app support works there is being able to call into that Graph API to see which authentication context values are available in that tenant.
Thank you, Caleb. Yes, there is a lot to unravel here. Some of the questions you have here around like multi-tenancy and how do you cook it into the app are things that I actually will cover in a quick few minutes. And this is where the using Microsoft Graph to save the mapping in your application is important, is because the authentication context will differ from tenant to tenant, and we have a code walkthrough as well. So moving on. So we created the auth context, we put it into the various policies we have. Now, what we do in our web API or the service application is that we enumerate existing auth context via Microsoft Graph, and then we are saving it against our local actions. So, and then what we do next is that we look for a claim called Authentication Context Requests, or ACRS. And if it is missing, we raise a claims challenge. So just bear with me. And now we will have a code walkthrough where I will essentially show you right in the code what's going on. OK, so this is the code. This is our service. The service is what you saw here, where we were able to basically configure the authentication context against the various operations that my service has. And in my service, let's start from the admin controller where we are doing the configuration. So in this action, what we do is the very first one that you saw, which was to basically create or fetch. In this case, we make a call to Microsoft Graph, and we have a class in the sample, sorry, really long named one, Authentication Context class reference operations, which basically uses the Microsoft Graph Beta SDK to give you a list of methods like list, create, update, and you can use this to read, write, update the existing auth context. We would not advise you to create or edit auth contexts as an app developer. Most app developers should be basically just reading the existing ones. And once you read those, you basically then have the capability where you go ahead and save them against some of your operations. So in this case, what we are doing here in this code is reading it, and then we have defined a bunch of actions. So in this sample, we defined 2 actions which are essentially tied to the with 2 events, two MVC events, which is for post and delete. And these can be mapped to a auth context. So why do we do that? So again, the key here is that you should be mapping it to your auth context in your DB. So what this code does is that it saves it in the local DB and it uses it later on. I'm going to just show you how it does it. So when I made this, when I saved this, and this is my data that I've saved. So essentially, I saved that C1 auth context ID against the delete operation, and that's what basically triggered the user to be sent back to the Azure AD endpoint for getting the policy satisfied. Now, this is part 1. So once you have saved it, what I have here in to-do list controller, a special method called check for required auth context. So it takes the name of the method. In this case, the method is either post or delete. What it then goes on to do is that it looks for a claim called ACRS. If it doesn't find one, obviously, it will throw an exception. Or if it finds it, it checks if the ACRS claim has the auth context ID. The ID is essentially C1 and C2. And I'll just show you an example of how the token looks like. If it doesn't see the required claim, it will throw what we refer to as a claims challenge. Now, this is all defined for you in the documentation we share. We hope to basically move this code into the MSAL libraries in the future. But at this point in time, this is a special kind of a message that you have to raise. You can use this code to learn about it. So essentially, you are basically saying, hey, you are throwing an unauthorized access exception, that is the HTTP error code 401, back to the user, asking them to go and with a set of claims, and you're requesting a claim, which is your authentication context ID, which is C1. So bear with me for a second, is because I'll just walk you through. So what this service does is that for each of its operations, it checks for an auth context. So it first makes a call to its local DB, see that if there is an auth context ID saved against this particular method that is being called. And if it is, and the ACRS claims does not have that auth context ID in the token, it raises a claims challenge. I'm going to just stop here and basically show you the actual token, because I know there is a lot to process here. So you saw how this works in the service setup. Just to summarize, the admin had defined auth context in the portal, then they created CA policy, then the IT admin, and it could be app admin, basically they access the admin site. You query the existing auth context using Microsoft Graph. You will be given a list. You save your actions against your applications, actions, or whatever you want to call them, against these auth context values, and you save it in the local DB, and then you use it. So we just had a service walkthrough. So this is how an access token looks like. So this is an access token for my web API, which is what you can see in the very first claim, the odd AUD claim. And it has a set of usual various scope, app ID, and whatnot. Now, but what you will notice here is that it does not have a claim named ACRS. So what happened the first time when the user sent this to the service, when they were trying to delete a to-do list item, the code basically said, nope, I need an ACRS claim, and can you please respond to this claims challenge? So this is how the claims challenge looks like, and this is what I wanted you to basically just punt on for a while, because it's not that straightforward to create. So among other things, it has in the bottom line something called as claims, which is essentially the service or web API telling the client that I need these extra claims. It reads like this. If you can see that it's basically saying that, hey, in the access token, can we get the ACRS claims, and it should have a value of C1 if you want to delete. The clients need at this point in time to redirect the user back to Azure AD with what's called as a claims request. Sorry, this is a lot of things to explain. So the claim that we are requesting back from Azure AD is ACRS, and this has a auth context ID. Now, when Azure AD sees that, hey, there is a application, is the client application asking for a claim called C1, claim called ACRS with a value of C1, it goes through its various conditional access policies and finds out which policies need to be satisfied before Azure AD will issue that claim back to the client application. In our case, we have one policy, conditional access policy, that requires the user to do an MFA, and that's exactly what the user did. The moment that is complete, Azure AD basically at another access token. Sorry, I'm going to show the access token, which has this, again, the same set of claims, but in this time, we also have a claim called ACRS, and which has a value of C1. When this is sent to the web API, the web API is able to, again, in the code that I have just discussed, able to see that, yes, ACRS claims is present, it has a value of C1, so the user will be allowed to delete a to-do list task. So I'm going to just repeat this one more time to make sure that we have covered all the topics and introduced it to you. So in the service app, you first, after you have saved the auth context ID against your application actions, you look for a claim called ACRS, and you are searching for the expected auth context IDs. If you don't find them against the saved actions, you raise a claims challenge. In the client app, when you get a claims challenge, you do a claims request, which is essentially redirecting a user back to Azure Active Directory with the claims needed, which has the auth context IDs for Azure AD to able to enumerate all its conditional access policies to find out what actions need to be, what policies need to be satisfied before Azure Active Directory will issue that auth context in the claim requested. So this is how a claims request look like. Again, this is something that we do very well within our Microsoft authentication libraries, but I've just put it here for reference. Essentially, it's the same thing. The claims request is taking the user back to login.microsoftonline.com/authorize, and it has a special parameter called claims, in which we are saying, can we please have the ACRS claims with a value of C1. Azure AD does its magic, and after the user has satisfied that, the various policy requirements, they're issued this claim. And before we move to the next part, I'll just show you what we did on the client. So now in the server side, you saw that we had a bunch of code, but in the client side, it's actually much simpler. So going back to our code again, this is our server. We raised a claims challenge. Now we'll go to our to-do list client where we are handling this. So the way we handle this is just this. We are using the Microsoft Authentication Library, the Microsoft Identity Web. And what we do here is in our action. So this is where, let's go to the delete method. So when a delete is called out, we basically look for an exception, and you can see how it is done in the code. It's a little too much for this call. All we do is we extract the header value, which is nothing but the claims that we need, and we use the consent handler class, which is part of Microsoft Authentication Libraries, and we call the challenge user method, and it does all the redirection and getting the new code token and making sure that it has the necessary claims and things like that. The moment you have it, and this is all done. So this is all you need to do in the client app today. We have managed to extend our consent handler in the authentication libraries have been around for a long time because we have been throwing these exceptions, claims challenges, and doing claims requests for conditional access engine for a while now. We hope to basically move some of this code that we have here, including the one that basically creates a claims challenge in the libraries itself. But till then, if you are interested, you can use it. The format we are using, it's called the claims challenge, and claim request are defined formats in the OpenID specification. It's nothing specific to Microsoft. If you're using a third-party OpenID compliant library and it supports these, the challenges and requests, you should be able to program against this scenario as well in the language and platform and library of your choice. So that was the client walkthrough. I'm gonna just quickly summarize this for you one more time, and then we will take some questions to make sure that we have covered this all for you. So here is it. It looks very dense, but it's actually not a lot if you look at what we have done so far. We have a user, we have the client app, which is the web app, the API, and the Azure Active Directory. In the first instance, the user basically signs into the web application. The client web application takes the user to Azure Active Directory, where the user receives an access token for the API, and then user starts to make calls to API. The web API always checks into DB if there is a requirement for an auth context. If not, it basically keeps returning data as expected. Now, when it conducts a high privileged actions, like in this case, an activity to delete a to-do list item, the safe settings in the API say that no, it requires an auth context. In this case, a claims challenge is thrown. The client web application uses the consent handler class to send a claims request back to Azure AD. Azure AD enumerates its policies to looking for how to satisfy all the various auth context IDs that was presented. Takes the user and asks them to do all the actions that are required. A new access token is issued, and the users can now start making calls without having to go back to Azure AD again. So yeah, that's like the primary meat of the demo. And at this point, I'm going to pause and see if we have any questions. For a desktop application, does it require web view too? So the question is slightly orthogonal. Anywhere, if your application can render, or in this case, WebV2 can render the Azure Active Directory's login screen, it will work because there is nothing special that is going on. It's the same login screen where you use to sign in, provide credentials, change your password, respond to get a message asking you to respond to an MFA. So this particular feature has nothing to do with the actual capabilities that of rendering the Azure Active Directory's authentication screen. Can we do the claims request in Angular using msol.javascript? The answer is yes. We only have a .NET sample now, but I believe we should be having these samples in other languages in the next week itself for JavaScript, and for Python and Java maybe in the coming months. I will then move to the next feature, which is called client capabilities. Client capabilities is optional. It's actually something that you might have seen in our code, where what you do, it's useful if you are an app developer and you have an API which has to support legacy clients which do not understand the claims request and claims challenges, and you might want to continue to basically change your behavior depending upon whether the client is capable or understands the new protocol extensions. And in this case, basically make sure that you don't send claims challenges to clients who do not understand them. It is baked into our code. Essentially, it is sent to you in a claim called XMS_CC, and we only support a value of CP1. I'm sorry, I will not be covering this in detail. It's explained in much detail in the documentation and the code, and I would suggest you use it if you are interested and you want to support this in your application. CP1 is the only value that's supported. And if you do this code to support CP1 and the consent handler to redirect the user for claims request, your application will automatically also support continuous access evaluation challenges from Microsoft Graph. So that's one of the benefits of using claims request is if you are using it in your app today. So this is how a token looks when you have the client capabilities enabled. You need to do this today if you have a token access token for Microsoft Graph and you expect to attend to the claims challenges that Microsoft Graph throws when continuous access evaluation events occur. One more thing that we wanted to cover before we finish this is understanding the personas and responsibilities in case of using an auth context. This is a context where you, as a developer, you have to work with your IT admins. It's not something that you can achieve alone as a developer. The reasons are quite straightforward. The conditional access policies are almost always crafted and maintained by IT admins. It requires the person who works with CA policies today needs to have a good understanding of the resources available that policies can be applied to, like how many users of the tenant are actually equipped to use MFA, or so they basically can make these decisions better than developers. So it is always good to let the IT admins define the auth context, use them into the CA policies, and developers should basically, we advise them to start using the auth context via Microsoft Graph. Let the IT admins do the definition and the policy crafting. From a developer perspective, you should only be using Microsoft Graph to first see what auth contexts are available, and then accordingly use them in your application. This will keep the bridge well working for you, especially if you have your ISV who is building SaaS applications and you have to work in multiple customer tenants. The availability of auth context will differ from tenant to tenant. So it's quite important that you use the Microsoft Graph API to enumerate and use those rather than to assume and use something like C1 or C2 hard code it in your code today. So that is all that we wanted to present. So I'm going to just quickly wait and see if we have more questions. Is this production ready? It's in public preview. Caleb, you want to take a shot at that question?
Yeah, so it's in public preview. I think it was mentioned earlier. It's rolling out, so you may not see it like in your Azure AD admin experience right now, but it should be there within 1 or 2 days. If it's not, the documentation, the sample and everything, and like the Graph API documentation is all out there and published. So you can start looking at that. And as a public preview, it's, you know, supported as a standard with standard public preview on there that, you know, we're learning in terms as we do it. So there could be some changes. You can go through support, like there's support has been brought up to speed on it, and that channel is available.
Okay, thank you.
So there is another question around how to satisfy some of these policies. I understand that the policy definition and applicability differs from clients and operating systems and the tools being used today. The feature in itself is not tied to those. I understand we have some challenges there in terms of policy implementation and rollouts. This particular topic is more for the app developer to demand authentication context and remain in a space where they're not really even aware of what CA policies are out there. They basically just work with these auth context IDs, C1 to C25, and the actual applicability would always be with the IT admins who would be able to craft policies depending upon the limitations or the capabilities of end users and devices. That's the best answer I can do. We will share the deck itself. It has all the links again in the end. And so here are all the resources that we have made available, starting from the developer's guide, the Microsoft Graph documentation, the code samples. We discussed claims, challenges, claims requests. These are a little bit too complicated, and we want to make sure that it's hidden in MSAL. But today, if you want to try it out, you need to just understand what this is. Then some standard documentation on the identity platform and the libraries. And then if you are new to conditional access, there are some links on the bottom that will help you get started on those. At this point, I'm going to hand it back to Stephen to close the call.
Yes, thank you, Kalyan, and thank you everyone for joining us today. You can find the call in YouTube next week. Thank you. Have a great day.
All right, thank you. Thanks, everyone.
Thank you, everyone. I hope this was useful.
Thank you.
Have a great rest of the day, everyone.